Hello to my statistics classes. We are going to be going over how to do problems from section 9.4, Inferences between Dependent Samples. I have a little cartoon here that I used to put up at the front of the class around this time of year. The snowmen playing with the playing basketball, and then it gets warm and the snowmen are gone. It's kind of ironic because basically that's what's happened anyways. Nobody's out playing basketball together, but we'll get through this. We'll get through it. So what I would like for you to do is to take a look at section 9.4. Now, section 9.4, I have this that I printed out. These are the problems we're going to be using, and I know we can't see the whole screen, so I'm going to try and adjust this. This is going to be a learning curve for me. So I'm trying to adjust this so you can see it better. Actually, I should just zoom in. But this comes from your book, and we're talking about inferences between dependent samples, which means you're going to be comparing ordered pairs. So basically the problem that we're going to be doing is the one about there being a difference between the weights of college kids from September to April. There's supposedly a famous, infamous 15-pound weight gain, freshman 15. So we're going to be looking at that information and we're going to compare and see if there is a difference between those two. And what we have here is a number 9. I'll read it to you. Does the BMI change during the freshman year? Listed below are body mass indices of the same students included in Table 9.1 on page 489. The BMI of each student was measured in September and April of the freshman year based on data that came from changes in body weight and fat mass of men and women in the first year of college, a study of freshman 15 by Hoffman, Policastro, Quick, and Lee, Journal of American College Health. So this was actually done. Use a 0.05 significance level, that's alpha, to test the claim that the mean change in the body mass index for all the students is equal to 0, which means there's no difference. Does the body mass index appear to change during freshman year? Okay, so in number 10, we'll be finding a confidence interval. So what you can see there is listed, there are 5 different people, and they checked the person's body mass index in September. For the first one was 20.68, in April it was 20.15. Okay, so what we are going to do is we are going to set up a hypothesis test to test the claim that the mean, this is our claim right here, test the claim that the mean change in BMI for all students is equal to 0. So what I've done is I've written these values down. And I need to adjust this again so that you can see it. Move this up a little bit. There we go. Okay. Sorry guys, there will be periods of adjustment for me. All right, so I have all of those values written down there. This will be very similar to all of the other hypothesis tests that we've done in the past. So what we need to do is we need to come up with a null hypothesis. And the null hypothesis in this case is that the mean difference, and I use a little subscript D, is equal to 0. Always equal to 0 with a null. The alternate hypothesis in this case, remember that the claim that they were making was that the mean change for all students is equal to 0. So this is our claim. So since the null is our claim, that means that the alternate hypothesis has to be not equal. They didn't say less, they didn't say greater anywhere in the problem. They also told us that we want to use a alpha is equal to 0.05 significance level. And now what we will do is we will draw, this is a t-chart. We're going to be using t-values. We're going to draw our little t-distribution, get our critical areas. We know that it's two-tail, the area in two tails, and they have to be equal to 0.05. So we go to our t-chart. If you don't have one at home, you can always look it up online. They have charts on Google all over the place. So this critical value is negative 2.776, and because it's symmetrical, the critical value on the right side is exactly the same value, but positive. So those are our critical regions. Now what we have to do is we need to find the t-test statistic, and we need to find the p-value. Now here's where it's a little bit different. So what I have to do is I have to turn my calculator on. I don't know if you can see that. But what I'm going to do is I'm going to put the April values in L1, and I'm going to put the September values in L2. So I'm going to download those values. L1, 20.15, enter. 19.24, 20.77, 23.85, enter, and 21.32, enter. I'm going over to L2 and I'm going to put the September values in there, 20.68. Oops, I put 3. I know you guys are probably screaming, no, you put a 3. Thank you. 19.48, 19.57, 24.57, and 20.96. Uh-oh. Yep. I made a mistake somewhere. Well, that's good because then you can see that I've made a mistake. Oh, I see, I forgot to enter. So I'm gonna go over here. I'm gonna start deleting these things out. I knew I couldn't have 24.57. Delete, 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 delete. I forgot to enter that. Enter, and 20.96. It's good that I make a mistake so you can see that how to fix them. Okay, now I have L1 and L2. Now what I want to do is I want to find their differences, and what I could do is I could take 20.15 minus 20.68. I could do all of those and slide those into L3. But instead, I'm going to go over to L3, go to the top. I have to be at the very top. L3 is highlighted. And then what I'm going to do is I am going to go and I'm going to put L3, and what's going to happen is, oh, that's an equal sign. I am going to put L1 minus L2 down there. And the way I do that is I look at the list. So you can see, scroll that up there a little bit. L1 is right here under 1, but I have to hit the blue key first to get it. Oops, L1. And then I hit minus over here and the minus signs. And I put in L2, which is by the 2. And now when I hit enter, the nice thing about this is L3 understands what I asked it to do. And it does it for me. Now you don't have to copy those numbers down or anything. But what we're going to do now is we're going to be doing a t-test with this information. So I'm going to bring this back. And I'm going to go to Stat, I'm going over to Tests, and I'm going to do the t-test for this one. I'm going to be using the data that I have. I'm going to hit that. And I'm going to go down here to the mean. I'm going to say that it's 0. And the list that I'm using is now L3. Make sure you change that. L3. And the reason why I'm using 0 is because that's what my claim was, 0, that there was no difference. Okay. And I'm going down to not equal. I hit enter. And then I go to calculate. And it gives me my t-test statistic as being 0.0402. Remember, we're going to use 3 sig figs for that. So I'm going to write that down. My t-test statistic here is 0.0402. My p-value is 0.9, let's just make it 0.970. And you can see that it told me I had 5 values. Now, if I made a mistake and I only entered 4 values for one of these lists and I entered 5 for the other, it needs it to be ordered pairs. So it will throw back that I've got an error, that I need to have the same exact number in L1 and L2 of values in order to be able to do this. So again, what I want to tell you that's different about this one is when you go to Stat and you go to Edit, in order to get the difference, L3, you have to go to the top. So you would have gone up to the top, and then you would have hit second L1 minus second L2, and it would have done it. It's already been done, so I just wanted to show you that again. And then you use the t-test to find that. Now, looking at our information, our t-test statistic, if this was 0, because remember this is a number line, if this was 0, it's very close to here, and remember this is the null region here. Also, our p-value is high, it's greater than our alpha value. Our alpha value is 0.05. So if you recall, p is high, the null must fly. I'm coming back up here, I'm circling my null hypothesis. So we fail to reject the null hypothesis. Now, having failed to reject the null hypothesis, I go back up here and I look and I circled, that's my claim. The null hypothesis is my claim. There is sufficient evidence to support the claim. Now, sometimes at this point in time, I like to look back at the problem to see exactly what the claim was. And if you see here, I've underlined what the claim is. The claim that the mean change in BMI for all students is equal to 0. Mean meaning average. So what they're saying is that the thought process, sorry about that, the thought process that all freshmen, when they go away to college, they gain 15 pounds is not true according to their study. Now, the next part, which would have been number 10, I'm going to put that back up here. You can hear my dog tapping across the floor. Number 10 says, use the same paired data from exercise 9 to construct a 95% confidence interval estimate of the change in BMI during freshman year. Does the confidence interval include 0, and what does that suggest about the BMI during freshman year? So this is just another way to show results from their tests that they did. So I want a 95% confidence interval. I'm looking for this value and this value. And if you recall, we're going to use the t-interval. Okay, I have to pause right now because my dog's ringing the bell and she keeps going crazy about it. So I am going to stop here for just a second so you'll notice a little blip in the recording.